Our next speaker is Kaivan Kamali of Penn State University, and he's going to be talking about iRODS as an object store for the Galaxy platform.
Thank you. My name is Kaivan Kamali. I'm a member of the Galaxy team at Penn State University. I'm going to be talking about how we integrated iRODS into Galaxy. So the first part of my talk, I'm going to be briefly talking about what Galaxy platform is. And the second part, I'm going to talk about how we updated the object store in Galaxy to allow iRODS support. So what is Galaxy? It's a computational workbench used by thousands of scientists around the world to analyze large heterogeneous data sets. The data could be bioinformatics, chemistry, ecology, and other data sets. A lot of information can be found on galaxyproject.org about what the Galaxy platform is. Basically, it's easy to use because it's GUI based, so you don't have to have any programming experience. It's web based, so you don't need any system administration experience. It's free and open source. There are over 8,000 tools available, and it's expandable. So if you have any tools that you want to be part of the Galaxy platform, you can wrap it and add it to the tools. It's popular, many citations, and there are also extensive tutorials available via the GTN Galaxy training network. What's going on? I have the presentations in my laptop. I don't know if you...
It looks like it got corrupted.
Yeah.
Yeah. Okay. Got the different. Yeah. Okay. A suggestion. Is that
Okay, that's
okay?
better.
All right.
Thank you. Maybe maximize it. Oh, I'm pushing my luck.
Yeah.
Anything that works.
Right. Where is it? Top right? Yeah.
Okay. Okay, so this is the Galaxy interface. There are 3 panes. On the left-hand side, you see the tools. Common tools are under the same header. For example, text manipulation. You can find, if you click on it, you can find a bunch of tools related to text manipulation.
Sorry, I forgot one more thing for the virtual folks.
Oh.
Thank you. Zoom. Did anyone see Zoom go anywhere? Oh, okay. We got to share this. Okay. Sorry again. Okay.
Thank you. And on the right-hand side, you have your analysis history. Any action that you do as part of your analysis is recorded there. And the center pane, you can specify the parameters for a tool or see the outcome of the file that is generated as the output of a tool. One of the main benefits of Galaxy is that you can extract frameworks from your analysis history. What that means is that every step in your analysis and the order can be captured in a workflow. And what this does, there are multiple benefits. One is that this allows for reproducible research. Big problem in computer science, my field, is that a lot of the research that's done cannot be reproduced. But if you do your analysis in Galaxy, you extract a workflow, specify the input parameters, your output would be reproduced because not only the steps are captured in this workflow, but also the version of the tools that you use for analysis are captured, and also all the dependencies, the environment that you use to run those, they're also captured by Galaxy. So it allows for transparent research. You can share your workflows, history analysis. You can share with the specific users. You could share it via a link. Anyone with access to the link would have access to it. And also, if it is something that's generic, you can publish it. So anybody else that wants to solve the same problem can use your workflow, so they don't have to reinvent the wheel. Uploading data, you can upload data from your personal computer, you can upload it from a URL, or you can upload it from certain online resources. For example, UCSC has a lot of data, genomics data. Galaxy supports a range of data formats and translation between those data formats. And Galaxy also provides substantial CPU and disk space. So every user gets 250 gigabytes of storage, and you can run your jobs on our servers for free for multiple days. If you want to do that on Amazon, obviously you have to pay. For example, on galaxy.org, that's the main server in the United States. The median size of data sets created by all users per day is around 8 terabytes. So this is how you upload the data. You click on that upload data button on the left-hand side. In this case, I selected it from my own computer. You could select it from a URL or type it in or paste it. After the upload completes, you get a green button on the right-hand side. And if you click on that I icon, you see the contents of the file, 1 column, 5 numbers in no particular order. So let's say this is a simple case. I just want to run a sort tool on this file. I'll search for sort on the toolbox search tool over there. I find the tool. These are the parameters. What's the input? It's the input file aptly named. How many columns? Do you have a header? How many columns? You specify that. Which column you want to sort on. In this case, it's only 1 column. You might have a file with multiple columns, and you want it sorted ascendingly or descendingly. And after you run it, you get another file that's the output of your tool. You look at the contents by clicking on that I icon, and now you see that the data is sorted. So you can do complex analyses, not necessarily sorting, and repeatedly. And all of those are captured on the right-hand side in the history, which you can then extract the workflow. So Galaxy comes up with a bunch of data visualization utilities as well. There are 3 main servers, the US server, Galaxy Main, the European server, it's hosted in Freiburg, Germany. Yesterday, they reached 50,000 users, and Galaxy Australia. There are other servers in Belgium and other countries. There are a bunch of private servers, which we necessarily don't know about, but I know that NIH has a bunch of servers internally. And there's also Galaxy Training Network. The community provides writes tutorials for every aspect of Galaxy. The tutorials are tailored for scientists, developers, and admins. And they have slides, hands-on section, data sets, workflows, and videos, many topics and tutorials and contributors. Okay, so Galaxy Object Store. This is what was modified to support iRODS. So Galaxy Object Store is basically the data virtualization technology. It abstracts Galaxy's business logic for data persistence, technology, and topology, and makes it possible to store data on a wide variety of persistence data, whether it's a local storage, cloud storage, and so on. It also helps the admins because let's say you want to add additional persistence media to an existing file system because it's running out of space. It allows you to do that without moving all of the data to a new storage. And you can also replicate the data, which is good for fault tolerance. If something fails, you still have a copy of data available. Galaxy Backend is any persistence media that Object Store can read from or write to. The list of backends that Galaxy Object Store currently supports are local storage, disk, network attached storage, cloud, and most recently the iRODS. Data distribution, if you have multiple backends, you can provide nested relationships between them. There are 2 data distribution protocols, hierarchical backends and distributed backends. If you have a hierarchical backend, the order in which the writes are done is specified. Reads, you go to any backend that has your data. But if you have a distributed protocol, you randomly write to backends based on some specified weights specified by the admin. Again, reads go to wherever the data is. So hierarchical, as I mentioned, is useful when you've been using a backend for a while. You decide to extend it by adding a new backend, but you don't want to move the whole data just yet. So you can read the existing data from the old backend and write the new data to the new backend. And distributed is actually pretty useful for the case that we have right now. We've added support for iRODS, but we don't want to release it all together at once. So what we do is we can have a distributed data object, and we pass some of the writes to iRODS, maybe 10%, 90% goes to existing disk. That way we can incrementally increase the weight of iRODS, and it gives us some basically allow us to roll back if something happens. So this is the iRODS object store, Galaxy's iRODS object store. It's an XML format. You know, you specify the type, username, password, the name of the resource and the zone, connection, host, port, timeout. I'll speak about the refresh time in a little bit, and a bunch of directories for jobs, cache, and temporary folders. So the iRODS object store reads and parses this XML configuration file and instantiates an iRODS object store class, which is a subclass of Galaxy object store. So what that class provides is a bunch of methods to create, get, and delete a file, and a bunch of utilities to get the file name, file size, file path, is the file empty, and so on. Obviously, there are some object store specific methods, but these are mostly common. And the iRODS object store class uses Python iRODS client to interact with the iRODS server. So that's what is using under the hood. So we implemented the iRODS object store class, which is using Python iRODS client under the hood. We wrote unit and integration tests, had the PR reviewed and merged, and we configured Galaxy to use the iRODS server. Our iRODS server is on Texas Advanced Computing Center in Austin, and we deployed a Galaxy server with iRODS support to our test server, which is testgalaxyproject.org. We usually first deploy software to test. We waited and tested there a little bit. If all is good, we push it to production. So we had a few challenges when we moved the software to test. The first challenge was Galaxy would create and maintain a session on startup, and session has a pool of connections, which is used by Galaxy to interact with the iRODS server. In the log, I would occasionally see a network exception error, and it seemed like some of the older connections were being dropped. So I went to iRODS chat. It's a Google group. It's very helpful. People comment there and help you out. And I had asked a question, and the suggestion was that I need to create a session every time I'm interacting with iRODS. So I implemented that, and the network exception error went away. But creating and destroying a session is pretty expensive, and we have thousands, tens of thousands of uploads and downloads, and that affected the performance negatively. So the solution was that we're gonna create and maintain a session. We're not gonna create and destroy it for every interaction. However, we added a flag timestamp to every connection that had its creation time. And every time we get a connection from the pool in the session, if the creation time was more than a user specified value before, we would recreate it. Otherwise, we would use it as is. So initially, we started with 5 minutes, which is 300 seconds. That's the refresh time. And this caused the network exception error to go away. And we also avoided creating and destroying a session for every call. So it was performant, and it solved the problem. The second challenge was that the Python iRODS client's post and get methods were not performant, and that would slow down Galaxy's post and get operations, especially for larger files. Our benchmark was iCommands, which is very, very fast. I think it's using a C library under the hood, and the Python iRODS client wasn't as performant. So I had multiple meetings with the iRODS folks, and initially the idea was that we're going to come up with a client-only solution that provides multi-threaded put and get, but eventually that solution was scrapped, and it was decided that we're going to, actually the iRODS team is going to decide that they're going to create a solution that's both client and server, involves both client and server. So clients after version 0.90 and servers after 4.29, they support multi-threaded put and get. And this is on automatically. You don't have to do anything. And any file larger than 32 megabytes, multiple threads are spawned, and the performance was improved. So in order to compare the performance, I wrote some scripts. These scripts would generate M file, that's a parameter, say 50, of size N, again, a parameter, maybe 100 gigabytes with random content. And I would first post the files to the iRODS server and average the runtime. And then I would get the files from the iRODS server, and then I average the runtime. And I repeated this for a bunch of file sizes, 100 bytes, 10 kilobytes, 1 megabyte, and so on. So this is the performance for post or put. As you can see, the client, which is in orange, yellow, is as fast or faster than iCommands, so that's great. This is the performance for get, and the client is again faster except for very large file size. I have to add a couple of caveats here. I did not run the 1 gigabyte test 100 times. I ran it maybe 30. If you run this 100 times, the numbers get much closer because all the other numbers were farther apart, but as more tests were run, then client did better. They also, we only get the file once and then it's in cache. So we don't care as much about get as we care about post. So the third challenge was after a while, the Galaxy server became unresponsive and it just hung. And I had to use PySpy to follow the stack trace, and it was hung in a Python iRODS client code. After extensive debugging, I found a bug in receive message in length. There was an infinite loop that would read from a socket and add up the number of bytes read. And if the sum of those exceeded the file size, it would break out of the loop. The problem was when you read a couple of times, and let's say the server went down, what you would read would return 0 bytes. And the loop termination condition never was reached. And we got into an infinite loop and it brought the whole app down. So I fixed that. Also found a bug with connection destructor, fixed that too. That was causing some leaks here and there. And then we managed to deploy Galaxy with iRODS Object Store to main, which is our production server. We, in order to test this in production, which is kind of a little bit dangerous, we created a group which access to Object Store was overridden to iRODS, and we added 3 people to that group. It was me, our system admin, and my boss, which is a heavy Galaxy user. I'm a developer. I don't use Galaxy as much, but my boss, he's a bioinformatician. He runs like crazy analyses. Tens of thousands of files are loaded, modified, and outputted. So he did not notice any performance analysis, performance issue, which is great. So what we want to do is we want to use a distributed object store next and route some of the traffic to iRODS, maybe 10%, 90% goes to disk, and just monitor it. And if everything is good, we incrementally increase the weight for iRODS. And the whole goal is to see if iRODS can sit on top of a real-time multi-user application where delays are kind of frowned upon, because the admin will receive an email and says, well, my job is running 5 minutes, what's going on? After that, when the 100% of traffic goes to iRODS, we still have data on disk that's being read, but we can transfer that via a separate process to iRODS and then retire the disk. So thank you very much. I also want to thank all the members of the iRODS team. This has been a long journey, and these guys have been very helpful, and especially Daniel and Terrell, which I've bugged them very, very much. Thank you.